Let us consider a scenario involving an unbalanced production line with machine failures and calendars. Consider an unbalanced production line with A. Fixed cycle times with no random variation at 8 workstations as 10, 10, 8, 10, 15, 10, 6, 9. B. A failure rate of 0.01 and a fixed repair time of 15 minutes for each machine on the line. C. A daily calendar of 480 minutes of available time and 960 minutes of unavailable time for each machine, out of 1,440 minutes of the day. D. The average daily demand of 32 pieces. The line cannot meet the average daily demand of 32 pieces during the currently available time of 480 minutes per day, irrespective of inventory limits at workstations. Here are 2 questions. A. How much overtime should you provide on a daily basis, with an increment of 30 minutes, to confidently meet the average daily demand? B. What are the optimal inventory limits at workstations in your production plan to meet the demand with minimal work in process on the line? On this 8-stage production line, let us consider cycle times which are entered now. Note that the 5th cycle time is the longest one. That is, the 5th workstation is the bottleneck on the line in this example. Now let us create 5,000 jobs for Monte Carlo simulation. Let us assign failure rates and fixed repair times and calendars to resources. Let us select 480 minutes of available time and 960 minutes of unavailable time in the calendar. Let us now simulate the production of 5,000 pieces. The simulation may take about 12 seconds. This is the simulation output in summary form. The average daily production rate is 27.88 pieces, which is much less than the required rate of 32 pieces per day. Let's now increase the available time by 30 minutes for each resource. Let us simulate the same production with an increase in available time by 30 minutes. The simulation output summary can be seen in the top row. Now, the daily production rate has increased to 29.71 due to 30 minutes of overtime. This rate is still less than the required rate. Let us now increase overtime by 60 minutes. That is, select available time as 570 and unavailable time as 870. Let us simulate the same production for the overtime of 90 minutes per day. Now the daily production rate has increased to 33.28, which is more than the required rate. Let us reduce inventory levels at all workstations except the bottleneck and simulate production again. The average work in process has come down from 22.43 to 14.38 as shown in column 6 without any reduction in daily production rate. In this window, we can see input and output of every simulation exercise on a given production line. For any exercise, the 2 tables contain the input and the corresponding output is shown in text boxes on the right-hand side of the window. This chart shows repair times of resources in red hash bars and unavailable times of resources in yellow hash bars.